Hello guys, have you ever wondered how AI remembers conversations, making every interaction feel personal and intuitive? Today we are diving deep into the fascinating world of agent memory with LangGraph. By the end of this video, you will not only understand how it works, but also how to implement it in your own projects. Let's get started. First, we are going to load the environment variable. For that, we are going to import load.env function from .env module. After that, we are going to call that function, which is going to load the environment variable in our notebook. Next, we are going to define our tools. So in this case, we have three tools available to us. That is multiply function, add function, and the divide function. Then we are going to put all these tools inside a list. We are going to create an instance of chat OpenAI. For that, we will first import chat OpenAI from LangChain OpenAI. And then we are going to create an instance of chat OpenAI. To bind the tools with the large language model, we are going to use bind tools function of LLM. And the instance of large language model, which is going to be binded with the tools, is going to be called LLM with tools. We are going to create a node that is going to be called assistant node. Now this node takes in a message from the user and then it sends it to the large language model to get a response. Now that response could be a final answer or it could be a tool response. Next, we are going to build a graph. For that, we are going to first do some imports. So first we are importing the start and the state graph from langgraph.graph. After that, we are importing tools condition, tool node, and to visualize the graph, we are importing image and display. We are going to build the graph by creating an instance of state graph with messages state inside it. The first node which you are going to create inside the graph is going to be the assistant node. Other nodes which are going to be the part of the graph is going to be the tools node. This tools node is going to have access to all the tools which we created. In our case, we created three tools, that is multiply, add, and divide. We are going to put an edge between start and the assistant so that the first interaction the user is going to have with the graph is going to be with the assistant. After that, the assistant is going to have a connection between tools or to the end depending on whether a tool is being returned by the large language model or not. For that, we are going to create a conditional edge which is going to start from assistant. The tools condition is going to decide whether to call a tool or to take the flow to the end. And at the end, we are just going to add an edge from tools to the assistant. We will build the graph, and this is how the graph is going to look like. Now let's see how exactly we can call this graph. For that, we are going to create a human message, and then we are going to invoke the graph in this manner. And as we can see, we get the answer from the large language model through our agent. So the agent is deciding which tool to call at what time. At first, it is calling the add tool, followed by the multiply tool, and followed by the divide tool. Now let's change the user message. Let's say I'm not making this call in one go. Rather, I'm dividing it into three different calls. Let's say I'm just saying add 3 and 4. Let's see what exactly it returns to us. Now let's check the messages. For M in messages, let's pretty print. And we can see that the answer provided by the agent is actually correct. Let's see what exactly happens when I'm going to send another message to the graph. For this, I'm going to create another instance of the human message. We are calling the graph with the invoke function, and we are passing the messages as an input to it. Now let's print all the messages which we have got as an output. Now, as we can see, the agent is not able to understand the context. This is what we would like to fix. And for that, we need to incorporate memory element. So LangGraph comes with a checkpointer to automatically save the graph state after each step. All we need to do is simply compile the graph with a checkpointer and our graph has memory. Let's see how it works. From LangGraph checkpoint.memory, I'm going to import memory saver, memory equal to memory saver. Then we are going to create an instance of the React graph with memory. Builder.compile, and we are going to specify the checkpointer equal to the memory we created. When we use memory, we need to specify a thread ID. This thread ID will store our collection of graph states. The checkpointer writes the state at every step of the graph. These checkpoints are saved in a thread. We can then access that thread in the future using the thread ID. Let's see. We are going to create a configuration. We will specify the thread ID, and then we are going to create the message. Let's call the graph now. The only thing which we need to add here is the configuration. Now we can check the messages. So this is the first message which we have passed to the agent. Now we can continue passing more messages to it, and the agent will remember what was the previous message being sent to the model. So let's create another message here. Multiply that by 2. Messages equals to react graph memory dot invoke, and we are going to pass the same configuration here. For m in messages, we are going to do pretty print. And voila, we can see here that the agent remembers what was the previous input which was fed to the agent, and then it is also taking the new message as an input. So it remembers what was the previous output, what was the previous input, and then it is concatenating the results as well as the input to my new message. And as we can see, the result is correct. And that's how you can add memory to a line graph. If you like the content, please do like and subscribe and hit the bell icon.